Okay, a couple of announcements here. First of all, Halloween today. Great job for those of you who decided to dress up. Good to see you guys dressed up. Other than that, I did grade your tests, and I will hand those back as soon as we get through today's lesson. Just wanted to give a little bit of extra time here, as I know people are walking on in. Overall, people did just fine. I think that we have a slight disruption in our schedule. I think we have a full week next week, but I think the following week there's conferences on Monday. Does that sound right to anybody else? And so conferences, instead of taking place in the evening, conferences are taking place from like, say, 11 a.m. to 7 p.m. And I think that parents could just come on in, or students could come on in, just open house type situation. You guys do not have school that day, which actually reduces in our number of instruction days when we do that, but that's just what it is. So, does that make sense? I'll send out information about conferences. I can't remember exactly everything that's supposed to come through the school, but I'll do my best to follow up with that. If your parent desires to not come in, but rather have a conference via like a Google Meet, we can do that as well. So I'll try to make sure that works out. Okay, so that said, we moved to, as I said before, this test that you took yesterday was over radicals. It used to be over radicals and rational expressions. So everything that we were doing now is what we used to do on that test as well, and it just got to be too much for people. So we decided to break it up in a couple parts, which proved to be good. One thing I handed out to you guys, along with your notes, is I handed out this sheet to you, just another factoring sheet. So the reality is that a lot of you are pretty good at factoring, and the reality is that some of you guys, you do struggle to come up with those numbers that say multiply 20 and add a 9. And those numbers will be 5 and 4. And so if you need help with finding those numbers, they are right here for you. So you can give that a glance as you work. So here we go. Simplify the following expressions. Rational expressions. Rational expressions are expressed as a fraction. I'm going to write this out once. I'm not going to write it out every time, but this problem is one that you've seen before. 54x squared. 54, I'm going to write it as 6x times 9x. And on the bottom, 24x, I'm going to write that as 6x times 4. And so when we go to reduce a rational expression, when it is written in factored form, factoring meaning it's written as multiplication, then we can start to cancel things off. Because this is equivalent to 6x over 6x, which is, times that 9x over 4. And who could tell me, what do you get when you take 6x and divide by 6x? You get just 1. So we have 1 times 9x over 4, so 9x over 4. This reduces not to 0, but it reduces to 1. So we have 9x over 4. So when you look at these, you can just say, well, what are 54 and 24 both divisible by? They're both divisible by 6. And the x squared and the x, you could take one of them out. It also works, again, I know you see subtraction here, so like Mr. Gens, you said you can't get rid of subtraction, but it's written as multiplication. It's written as 8x squared over 4 times x minus 3 over x minus 3. So those reduce to 1 as well. And so we have 8x squared over 4, which is just 2x squared. And so this is where I kind of lose my cool, is when people get to a letter like C, and they're like, you know what, I'm just going to cross off the x's. 20 over 10 is 1 over 2. 5 over 40, that's 1 over 8. And I get 1 over 16. Okay, that's completely made up math. It's very illegal, and don't do that. This is not written in factored form, so I need to write it in factored form. What can you factor out of the top? 5. You factor out 5, you're left with x minus 4. What can you factor out of the bottom? 10 and x, and you're left with x minus 4. Notice now it's very similar to the previous problem. The x minus 4s, those reduce to 1, and 5 over 10x reduces to 1 over 2x. Letter D is a little bit tricky. I have 9 minus x squared. That is the difference of squares. I could write that as 3 minus x times 3 plus x. Because the 9 is first, make sure that your 3's are first. Do not switch them around. That would not be equivalent. How does the bottom factor? x and x, but what are two numbers multiplied at positive 6 that add a negative 5? -2 and -3. And so now we're faced with a little bit of a predicament here. I don't see an x plus 3 anywhere than right there. And I don't see an x minus 2 anywhere other than right there. These two look similar to each other, but they are different, aren't they? For example, here the 3 is positive, but here it's negative. Here the x is negative, and here it's positive. Very important you pay attention to this step because you're going to use it multiple times throughout this unit. Anybody know how I make these two look the same? I'm going to factor out a -1. If I factor a -1 out, this negative x will turn to a positive x. And this positive 3 will turn to a -3. So all I did is I focused on that first term and I factored out a negative. If you're not convinced by it, if you were to multiply that negative through, you could see that you would get a positive 3 and a negative x. Now on the bottom, I have x minus 2 times x minus 3. Hello?
Hi, can you take a picture of people who are dressed up for Halloween?
Sure, if you're dressed up, go. You can see that the x minus 3 is reduced, and we get a negative quantity, 3 plus x, over x minus 2. And that's our result. I'm going to hand out the homework just to save time as they are doing their picture. You're welcome.
Now go to the now go to the That's it. You saw it in
Okay, we'll do example 2 here, example 3 on the other side. If you guys can do that first part, you'll be fine here. So we simplified rational expressions. Now we'd like to multiply rational expressions. And you have two options here. I'll show you the first option. You could go ahead and multiply the fraction. So as you multiply the top, you get a 12x. And as you multiply the bottom, you get 18x. What are both 12 and 18 divisible by? 6. And notice that the x's do reduce. So if you go ahead and divide the 12 and the 18 by 6, you get 2 over 3, and that is your result. That's not the way that I do the problem. Can I show you how I do it? I think it is a little bit easier. I look at 3 and 9. What's 3 over 9 reduced to? 1/3. And then I look at 4x over 2x. Everybody agree that that reduces to 2? So I get 2/3. So you can look across and reduce that way as well. For example, as you look at letter B, I notice that in this situation, the x plus 2's will reduce. You don't have to actually multiply them out all the way across the top. You can reduce across the multiplication sign. So that leaves me with 4 times x minus 1 over 12. We all know that 4 over 12 reduces to 1/3. So we have x minus 1 over 3. Part C, I can't reduce anything yet because it's not factored. So we go ahead and factor it. We can't factor x plus 5. There's nothing to factor out. Nor can we factor 3x plus 1. There's nothing to factor out. But what can you factor out of 9x plus 3? We factor out a 3, and we'll go after 3x plus 1. And then how does x squared minus 25 factor? X plus 5 times x minus 5. So, looks like we've done our work. Now that it's in factored form, we can look to reduce. The 3x plus 1's reduce, and the x plus 5's reduce. That leaves me with 3 over x minus 5. If you can factor in this unit, you're going to do really, really well on this test. The next one, again,
Can we borrow a gauge for pictures for tiger vision?
the next one we factor, x plus 3 times x minus 1. And the bottom, notice that it factors to an x minus 2 times an x plus 1. And we're going to pause. I look at the one on the top, I've got a 2 minus x. That's very similar to the x minus 2. Does anybody recall what I'm going to do to that 2 minus x to make it look the same as x minus 2? Factor out a negative 1, and you're left with a x minus 2 when you factor that negative 1 out. The bottom, we get the x plus 3. Let's look for what reduces. X plus 3's reduce, x minus 2's reduce. Don't forget about the negative sign. The negative sign attaches with the top, or with the bottom, or up front. So you have 3 ways you could write your answer. Negative x minus 1 over x plus 1. Or you could write it as x minus 1 over x plus 1 with a negative right in front. Or you could write it as x minus 1 over negative quantity x plus 1. So the negative goes either to the top, the bottom, or up front. Any of them is absolutely fine. And flip it. We do this and we're done. And I'll hand back your tests. Divide the following rational expressions. I don't divide fractions. I gave up on that a long time ago. Okay? I don't like to do it. What do I do instead? Multiply by the reciprocal. Let's make it easy. So, if you know how to, and you gotta understand from a teacher's perspective, this drives me nuts. I get to test and people are like, well, I know how to multiply, I just don't know how to divide. Bull crap. You know how to multiply, you know how to divide, right? All you gotta do is just take 2x over 3 and you multiply by 12 over 6x squared. That's all you do. You know how to multiply, you know how to divide. And now we get a bunch of problems that are exactly like the same as we did before. I multiply the tops. I think that's what most people would do, 24x, and the bottom, 18x squared. We worked on simplifying these in a previous unit. 24 over 18, that's going to reduce to 4 over 3. Next one is x minus 2 times an x plus 2 over x plus 1. And we're not going to divide, we're going to multiply. We go ahead and we flip that piece. Now we've written as multiplication, and we just look to see what is going to reduce here. And as you can see, the x plus 1's reduce, and the x minus 2's reduce. And so you're left with an x times an x plus 2. I'd like you to try letter C on your own. Please try letter C on your own. See how you do. Some people really like the rational expressions unit because they like crossing stuff off. Makes them feel good like they accomplished something. As a math teacher, it's important as we model stuff that we try to show all of our work. But I will say that I try to save a little bit of space and time when I do these, but I would caution you from doing too much work that you don't write down. It is difficult sometimes for me to follow people's work during this unit. One thing I do in this situation is I do this, I write 2 minus x on the end and a 3x plus 3. I just do that right away, okay? So I just, save space. I just, instead of rewriting the first part, I just go ahead and flip the second part and change it to multiplication. So I do like to make that quick little adjustment. Looks a little bit sloppy, but I'll admit that that's one thing I do, and I do understand when people do that. I factor the top to be x plus 3 times x minus 1, or x plus 1. How does the bottom factor? Two numbers multiplied, -8, that added positive 2. Positive 4 and negative 2. I got to factor my 2 minus x. What should I do? Factor out that negative, get a positive x and a negative 2. And then what do I factor out the bottom? 3. So, as we finish off our work for today, the x plus 1's reduce and the x minus 2's reduce. But without a doubt, when people write their final answer, can you see how people might forget the negative or the 3? Yeah, so it's important to remember the negative and the 3. So I'm going to write it as negative x plus 3 in top, and the bottom it will be 3 times x plus 4. So when you start going about your reducing, don't forget sometimes these constants and other things that can hang on out. That's good. Simplifying rational expressions. What we just did, that is something you did back in 9th grade. It's also something you did in Algebra 2. The difference is that you spent a week on it, okay? We spent 1 day reviewing that. We're going to go to adding and subtracting. We're going to go solving equations, and you're going to learn something new this year called simplifying complex fractions. So that's where we want to devote our time. We'll get good practice with this. If you take out your worksheets, you are only today working on this very front. This very front, that's it, okay? Go ahead and start working. In 5 minutes, I'll hand back your test, and we'll go from there. So you guys.
I left 5 minutes before I was supposed to be here.
No, I didn't say anything.
I got no school in the program.